Guys, here's what you missed. I am hiding upstairs in the bedroom because my husband, with his loud voice, is in a meeting downstairs. So I have to be upstairs so that way you can't hear him. So I bring Trump upstairs and we're sitting on the bed, and I was already recording a video for you. And my dog, who I love 95% of the time, jumped onto my computer, messed up the video. So I'm sorry you don't get to see that. And then he went into the closet and pooped. So I'm happy that's over. For you, it is Wednesday or Thursday, but for me, it's Tuesday, Taco Tuesday, Cinco de Mayo. So now that I've cleaned up this, I get to do this video with you, and then I get to go stuff my face with all the tacos, and I'm pretty excited. You guys did a really good job on the quizzes, and I can tell that you're ready to move on. Not all of my classes are ready to move on, so I just want to make sure that you understand how proud of you I am. Great job on the quizzes. Today we're going to learn about permutations. You will definitely need a piece of paper for your notes and also a calculator. So if you don't already have one, press pause and go get that stuff. I can't stop thinking about that big mess I just cleaned up, guys. Distance learning is a trip. I'm just trying to do my work, and my dog is going to the bathroom in my closet. Okay, so permutations. Go ahead and write this down, pause if you need to. Permutations is how many different combinations you can make of something. How many different combinations. The definition in the book doesn't really make that much sense, and the definition, if you want to look it up online, is very confusing, so I thought that I would just jump in with some examples. My first example is about a place that I can't wait to go back to, Baskins and Robbins. And so you know that Baskin and Robbins is famous for how many flavors? I'll take a hand. Yes, you in the back? That's right, 31 flavors. You see, I'm losing it now. My dog went to the bathroom in my closet. Can't focus on anything else. So we're going to Baskin and Robbins because you can get 31 different flavors of ice cream, but of course, you're not going to get 31 scoops. If it was an option, maybe we could, maybe I would, but it's not an option. So let's say that we're just going to do 3 scoops. So we're going to get 3 scoops of ice cream. They have 31 different flavors, and I don't want to have 2 scoops of any one kind. I want to try 3 different flavors out of the 31. So how many different possible combinations can I make out of those 31 flavors? Well, for my first scoop, I have 31 different flavors to choose from. For my second scoop, I already used one of those flavors, so now I only have 30 scoops to choose from. And for my last scoop of ice cream, I only have 29 different flavors to choose from. So I don't want to repeat any flavors. I chose 31 flavors. I chose out of 31 flavors for the first time, 30 flavors for the second time, and out of 29 flavors for the third time. So in order to find how many different permutations of these flavors I can make, how many different combinations of 3 scoops of ice cream I can have, I'm going to multiply these numbers. And so I'm using my calculator on my phone. And of course, I'm going to double check my work because anytime we do anything on the calculator, we should do it twice, unless you have a fancy graphing calculator and you know for sure you didn't make a mistake. This is how many different possibilities I have, 26,000, almost 27,000 possibilities of different combinations that I can have. 3 different scoops of ice cream, not repeating any flavors. So that's how we do permutations. If you have an exciting word problem, like my problem about ice cream, then it's going to be worded something like that. If your math book is lazy and doesn't give you a math problem, they'll ask you to do this. P and then in parentheses 31, 3. That means that you have 3 places to fill and 31 things to choose from. Let's look at some more examples. Pause if you need to, write stuff down if you need to, come ask me questions if you need to. I'm sitting in a Google Hangouts waiting for you. All right, Mr. Bernstein owns 14 paintings, 14 things to choose from, but he only has enough space in his home, wall space in his home, to display 3 of them at any one time. How many ways can Mr. Bernstein display the 3 paintings in his house? So here's the exciting word problem. Here's another way that you might see the same problem being asked. How many different ways can we display 14 things if we have only room for 3? So I'm going to do 14 times 13 times 12. 1, 2, 3 numbers, starting with 14. So for this first painting, he had 14 different paintings to choose from. For the next one, he only had 13 left, 13 paintings to choose from, and then 12 left for that last one. I'm sorry I don't have these answers for you already. So this is 2,184 different ways that he could display 3 out of those 14 paintings in his home. Pretty cool. Press pause, ask me questions if you need to. Otherwise, let's keep going. Make sure you're taking your notes. Next one. How many different two-digit numbers can be formed from the digits 4, 6, and 8? How many two-digit numbers can be formed from the numbers 4, 6, and 8? So, oops, I should go back and write it. If this was not a word problem, we have 3 things that we're choosing from, but we're only picking 2 of them. 3 things that we're choosing from, but we're only picking 2 of them. Let's do this one in the Edpuzzle. What's the answer for this one? You should have done 3 times 2. We're starting with the number 3 and we only have room for 2 selections. 3 times 2, that means 6 different two-digit numbers can be formed from the numbers 4, 6, and 8. 6 different possibilities. How many different 3-letter passwords are possible if no letter can be repeated? How many different 3-letter passwords are possible if no letter can be repeated? So I assume they're talking about the English alphabet since this problem is being asked to us in English. There are 26 letters in the English alphabet. What number should go here? What number would go here? That's right, we're going to do the number 3 because we're only looking for 3 different letters. The first letter we have 26 letters to choose from. The second letter we have 25 letters to choose from, and for that third letter we only have 24 letters left. Hold on, you guys should be checking my math also because let's face it, I've made like one mistake ever before, but I might make another one in the future, right? One mistake ever before. There are 15,600 different passwords that we could make. Oof. And so now when we make new passwords, it has to be like 6 characters long with a capital and a special character and a number. That is way more than this. So all of our passwords are very secure. In school, how many ways can a president, vice president, and secretary be chosen from 8 students? This one is also for your Edpuzzle. Go ahead. The math problem that we're doing, we're choosing from 8 different students, but we only have 3 selections to make. We're going to do 8 times 7 times 6. 8 times 7 times 6. 8 times 7 times 6 is 336. There are 336 ways that we could select a president, vice president, and secretary from 8 different students. Okay, here is your homework. You will be asked to answer some of these questions in the Edpuzzle next week. I think problems 8 and 9 are on page 770, but you know about that. Don't forget to do the 4 reflex and 2 Dreambox. This is going to be the stuff that raises your grade a lot if you did not do reflex and Dreambox during the school year. If you have any questions, you know where I'll be in that Google Hangouts. Now I'm going to go finish up your Edpuzzle and eat all of the tacos, and I'll probably love my dog again by the time I'm done with your Edpuzzle, which is good. He's cute 95% of the time. It's just when he's going to the bathroom in my closet. Have a good day, guys. Bye.